The e-bike market has seen significant growth, with adoption rates varying across regions like Asia-Pacific, Europe, and North America. Behind the impressive market projections lies a complex reality of technological advancements, environmental benefits, and practical considerations for solo travelers. Making an informed decision about e-bike purchases matters, especially for solo travelers who may find themselves in remote areas without immediate support. With both market and technical factors to consider, understanding the fundamentals of reliable e-bikes can save you from costly mistakes. By the end of this exploration, you'll understand which e-bikes withstand real-world solo travel demands, the specific components that determine long-term reliability, and the maintenance practices that extend battery life based on existing research. Understanding e-bike technology fundamentals. Let's cut through the marketing claims and break down what actually matters for reliability. E-bikes come in two fundamental designs that determine many aspects of their performance. Hub motors mount directly in the wheel, creating a simpler system with fewer moving parts. Mid-drive motors integrate with the bike's existing drivetrain, providing better weight distribution but adding complexity with more potential points of wear. The data shows that hub motors offer excellent reliability for flat terrain and consistent conditions, while mid-drives excel in mountainous terrain with their superior torque distribution and hill climbing efficiency. The battery chemistry comparison reveals important differences. Lithium iron phosphate (LFP). Batteries outperform traditional lithium-ion by offering 2,000 plus charging cycles versus 1,000 cycles, though they weigh approximately 20% more. This translates to a longer lifespan for solo travelers who prioritize reliability. For those crossing varied terrain, motor power requirements break down simply. 250 watts, sufficient for flat terrain and light assistance. 500 watts, the sweet spot for most solo travelers handling moderate hills. 750 watts plus, necessary for steep climbs with heavy gear loads. Actual range numbers often diverge from manufacturer claims. Real-world ranges typically decrease when accounting for headwinds, cargo weight, and elevation changes, making it important to research actual owner experiences. Based on the available research and user experiences, these bike categories represent strong options for solo travel applications. Urban and paved routes. Hub motor urban options. Hub motor designs offer reliability with fewer moving parts. Look for models with at least 50-mile real-world range. Integrated lights and fenders enhance practicality. Regular maintenance intervals around 500 miles. Consider their limitations for off-road applications. Mid-drive urban commuters. Mid-drive models with well-designed battery management systems. Advanced models can extend battery cell life significantly, typical range of 40 to 50 miles in real-world conditions. Note that proprietary parts may limit field repair options. Trail and mixed terrain. Carbon frame mountain e-bikes. Carbon frames with integrated protection for durability. Suspension systems with adequate travel, 150mm range. Quality mid-drive motors with 80 plus Newton meters torque. Field serviceable components are a plus. Higher cost reflects more robust construction. Affordable mid-drive trail options. Mid-drive motors with durable metal gears. Range varying from 30 to 50 miles depending on assist level. Water resistance ratings IP65 or better for all-weather riding. Comprehensive warranties are important. Consider service network coverage for your travel areas. Expedition and remote travel. Dual battery systems. Dual battery configurations for extended range, 100 plus miles. Factory-sealed electronics with high IP ratings. International service networks for global travelers. Carbon belt drives reduce maintenance requirements. Weight considerations become important. 60 plus pounds with dual batteries. Ruggedized adventure models, high-quality connectors and wiring. Reinforced frames tested for substantial weight capacity. Performance in extreme weather conditions. Hydraulic braking systems with redundancy. Availability in your region is an important consideration. Each category offers specific advantages for different types of solo travel. The research indicates that reliability comes from both quality components and appropriate application, using the right bike for the intended purpose. Common failure points and prevention strategies. Research shows that e-bikes have predictable failure points that smart riders can prepare for. The most common issues occur in this order. Battery management system failures. Prevention. Store between 30 to 80% charge when not in use. Avoid full discharges. Keep battery temperatures below 100 degrees Fahrenheit or 38 degrees Celsius. Consider adding a secondary inline fuse for protection. Controller issues. Prevention. Ensure proper cooling for electronic components. Never submerge electrical components. Apply dielectric grease to all connections. Use only the charger designed for your specific battery. Motor bearing problems. Prevention. Regular inspection every 500 miles. Apply appropriate lubricants to accessible bearings. Listen for unusual noises as early warning. Consider carrying spare bearings for hub motors on extended trips. Display and control failures. Prevention. Protect with silicone sealant where appropriate. Install handlebar covers in wet conditions. Carry backup control options or phone apps. Set up offline maps before departure. Solo travelers face unique reliability challenges. Without support vehicles, each component becomes a critical link in your travel chain. Testing shows that charging electronics are particularly vulnerable when exposed to moisture. Maintenance protocols for extended reliability. The difference between an e-bike that lasts 3 years versus one that lasts much longer comes down to these maintenance protocols. Weekly maintenance. Check tire pressure. Impacts range and performance. Clean chain and drive components. Inspect brake pads for wear. Verify all electrical connections are tight. Run battery diagnostics through manufacturer app if available. Monthly maintenance. Full system diagnostic check. Battery capacity test. Record results to track degradation. Torque check on all critical bolts. Drivetrain deep clean and lubrication. Software updates from manufacturer. Seasonal maintenance. Complete disassembly and inspection of drivetrain. Apply dielectric grease to all electrical contacts. Check motor mounts for signs of wear or cracks. Recalibrate battery management system if needed. Consider professional drivetrain adjustment. For solo travelers, these emergency preparedness items have proven valuable. Carrying a USB power bank as emergency backup power. Downloading motor reset procedures for your specific model. Installing zip ties and duct tape on frame for temporary fixes. Packing spare fuses and basic electrical toolkit. E-bike infrastructure and route planning. The reliability equation extends beyond the bike itself to infrastructure planning. Solo travelers need to account for charging availability and compatible services. Research suggests that e-bike travelers sometimes overestimate charging opportunities in rural areas. Many small towns lack reliable public charging options for e-bikes. While Europe offers more dedicated e-bike charging stations than North America, both regions face compatibility issues across charging standards. Effective route planning requires planning for a maximum distance between charges at 75% of your bike's rated range. Identifying alternative charging locations every 15 to 20 miles. Verifying accommodation policies for battery charging permission. Mapping elevation to calculate accurate range estimates. The charging network gap remains significant. Adapters exist, but they add complexity and potential failure points. Carrying your original charger plus one universal backup for international travel is recommended. Future technologies and evolving standards. The next generation of reliability features is emerging, with manufacturers implementing these advancements. Advanced battery management systems, better detection and routing of power around problematic cells, enhanced Bluetooth connectivity for monitoring, potential to extend usable life significantly, redundant control systems, function even if primary controller experiences issues, allow emergency modes at reduced power, accessible through smartphone backup interfaces, integrated diagnostics, systems that identify potential failures before they occur, record and analyze ride data to optimize performance, connect with manufacturer databases for known issues, field serviceable designs, components replaceable without specialized tools, standardized parts across multiple models, 3D printable emergency replacement options in development. Industry standards are evolving toward increased compatibility. New standards aim to create component interoperability across brands, potentially addressing the proprietary parts challenge that currently affects travelers. The most reliable e-bikes for solo travelers balance proven technology with maintainable designs. The research points to mid-drive systems from established manufacturers leading reliability ratings for complex terrain, while hub motors offer simplicity and reliability for less demanding routes with fewer mechanical components to fail. Your reliable e-bike journey depends on 3 critical factors: choosing models with proven field reliability, implementing regular maintenance protocols, and planning routes with realistic charging expectations. Remember that reliability isn't just about avoiding breakdowns. It's about having the confidence to explore beyond the reach of bike shops and support networks. Choose accordingly, and the road ahead remains yours to discover.